Okay, let us something discuss about the duct system. So basically, first, let us try to understand some points about the duct. Okay, like what is the meaning of duct and why this ducting is very important. Okay, so basically, when we talk about the ducting here, so usually this ducting system, okay, we can say that this ducting is basically used to supply the cool air, okay, to the spaces. Suppose, for example, if you want to supply 1000 CFM of air, I'm just giving one example. Okay, you want to supply 1000 CFM of air to 3 different rooms. Okay, room number 1, room number 2, and room number 3. So how you are going to supply this air? Because we require one medium, because air is dimensionless, okay, and obviously air can take up any shape. So that is why what we are doing means with the help of this ducting, we are supplying the quality air to this wherever we have to supply the air. Okay, see, basically air is always available. The very first question, like the very first thing what I will tell you, air is everywhere available, but here we are trying to supply the quality and cool air. So this is the reason why we are using the ducting here. So basically, when you check about the ducting, so ducting will be in two forms. Usually the ductings are available in rectangular form and one is available in the circular form. Okay. These are the two major types of ducting. Apart from that, we have the oval ducting also available. But majorly, we deal with this rectangular type of ducting or circular type of ducting. Okay. Now, the fundamental of duct. See how the duct system works. So you have to understand one example. Just example. For example, you have one truck here. Okay. And you are traveling from this truck from point A to point B. Suppose this is my point B. Okay. So what exactly happening here? Let us try to understand. Say this is my point A and this is my point B. So this point A is the one where truck is standing in its position. Okay, here what happens? Truck is not moving. Okay, so the truck is stationary, or we can say that this truck contains the potential energy. Say if we have studied in our school, so we already know that there are two types of energy. One is the potential energy, one is the kinetic energy. So kinetic energy is the one which is what you can say, which is generated or which is what you can say available when any object is moving. If the object is not moving, so it is called as potential energy. So here also the same condition. When the truck is stationary, it contains the potential energy. Okay. And when truck moves from point A to point B, it is moving with the help of kinetic energy. Okay, this is the basic concept. Similarly, when the truck is at stationary position, it contains the static pressure. You have to also understand that this truck contains a static pressure. Okay. And when the truck is moving, so it is moving with the velocity pressure. Okay. So this is the main thing. Just if you can mute it. So here we have understood that when the truck is stationary, it contains the static pressure. When the truck is moving, it contains the velocity pressure. The same concept applies with the air inside the ducting. See, when the machine is off, okay, when the AHU is off, so the air is in standing position. It means that it contains the static pressure. And the moment we switch on the fan, so what happens? Air will move with the velocity pressure. So this is the basic concept of the ducting system. So let us go to our topic here. Okay, first we will try to understand something about the ducting today, and then we will go for the calculations. Okay. So basically, as I told you that ducting follows the Bernoulli's theorem. Okay, and this is the example what I was telling. When the truck is in standing position, it contains the static pressure, and when the truck is in moving, or when it is moving from point A to point B, it contains velocity pressure. So your total pressure will become equal to static pressure plus velocity pressure. Okay. Similarly, same example is given for the balloon also. If you fill the balloon and you hold the balloon, so it contains a static pressure. And if you release the balloon, it will go out with the help of velocity pressure. So this is the very basic concept of the air which is traveling inside the ducting. Okay. So basically this ducting system follows the Bernoulli's theorem. So what is the meaning of Bernoulli's theorem means? When you increase the velocity, your static pressure decreases. So what do you mean? Suppose if you increase the velocity of the fan, say velocity is related with the, it is the term which is related with the speed, and speed is related with the motor. Okay, motor of the fan. So just understand that when you increase the velocity or RPM of the fan, so what happens? Your static pressure decreases, causing the total pressure to remain constant. This is the definition of Bernoulli's theorem. Okay. In simple terms, when velocity increases, static pressure decreases. When velocity decreases, static pressure increases. So this is the basic definition of Bernoulli's theorem. So our ducting system also follows this Bernoulli's theorem. Okay. So this is the very basic thing of the ducting. Now, as I told you, the example is given here. A truck parked at the top of the hill contains potential energy. So you can just go through this example also. Okay. Now, after that, so let me just explain you once again. Suppose this is my fan. Okay. And this fan is connected. No, sorry. The ducting is connected with the fan. So what happens? Suppose this is my ducting. Now, whenever the fan, now this fan contains motor also. Okay. There is a motor which is running the fan. So whenever this motor, or you can say when the motor is off, so the air which is inside this ducting, it contains the static pressure. Okay. And when the motor is on, the air will move in direction. Okay. So it is moving with the velocity pressure. So what is the total pressure of the fan? The total pressure of the fan will become equal to static pressure plus velocity pressure. So in our example, we have to always calculate the static pressure. So that is why we have the static pressure calculations. Okay. We have to calculate. Now, let us see some factors which are affecting our duct design. Say we have to design the duct system so that air can travel from one place to another place. But there are certain factors which has to be considered for designing the ducting system. So let me just write down the major factors which affect the duct design. The very first factor is the space. Okay. So space is a very important factor here. Okay. Just a minute. Okay. Now space is a very important factor here. So why this is very important factor means, see, okay. See, why space is an important factor means normally what happens when we see the ceiling area. Okay. So normally what happens inside the ceiling, we have the false ceiling. So from the false ceiling, all the services are running. For example, duct is running, electrical cables are running, or you can say plumbing pipes, sprinklers pipes, hydrant pipe, everything is running from the space. So that is why the space availability is very important here. You should select the space for the HVAC ducting in such a way that our HVAC ducting should not, what you can say, it should not hinder other services. Suppose, for example, if I get the false ceiling area of only 500 mm. So in this 500 mm of the area, all the services has to run. So we have to design our ducting system in such a way that all other services should be coordinated, or all other services should be accommodated here. So this is the very important thing. So how you can change the space means by adjusting the height of the ducting. Okay. So it's very simple. You have to adjust the height of the ducting. With adjusting, we can always check for the space availability. This is the very first point, space availability. Okay. And another factor is the installation cost. See, the meaning of installation cost means, suppose if you are designing the very huge ducting system. For example, I am just saying one example. Suppose if duct size is 500 by 300 and one duct size is 400 by 200. So in this, you can see that this 400 by 200 ducting will take less material, okay, as compared to 500 by 300. Suppose both sizes are okay, you can select both the sizes. So in this case, what you have to do means you have to also check from the installation cost point of view, because there are a lot of duct pieces which are running in the project. See, all the duct pieces are in small lengths, okay. So just imagine, just wonder, there are a lot of duct pieces which are running, and these ducts will cost a very huge amount in the project, okay. So that is why you have to always check which size should be selected, okay. This is a very important point. So suppose, for example, you are doing for the 1000 duct pieces. Suppose there are 1000 duct pieces, and in every duct pieces you have a choice. You can either reduce 100 mm height, or you can either reduce 100 mm width. So you should try to go for that in that way, because that 100 mm, it matters a lot when you are talking in terms of the volume. So that is why this installation cost is also very important. Now, how to identify that my installation cost is going to be less? For that reason, we have to follow one aspect ratio. I will explain you what is the meaning of aspect ratio. So with the help of aspect ratio, we will understand that what is the costing of our ducting. Lesser the aspect ratio, lesser the costing. Higher the aspect ratio, higher the costing. Okay. So this is the simple concept. So that is why what we have to do means always we have to check the aspect ratio also. We will come to that. Now, next important factor is the air friction losses. Now, this is a very important factor here. Your friction losses can be occur by various reasons. Okay. See, first try to understand the meaning of friction losses. Friction losses is nothing but the loss of air which is traveling from the ducting. Suppose if any air is traveling from the ducting because of any hole or because of any improper fitting, some air will be lost. So that is called as friction losses. So these friction losses are majorly, it depends upon the size of the ducting, shape of the ducting. See, how to understand shape of the ducting means, suppose for example, if I have a zigzag duct, suppose this is my one of the ducting. So in this case, what happens? Whenever the air is traveling, it will hit this surface, then it will come and hit here, and it will come and hit here, then it will come and hit here. So you can see that every point, the air is getting lost here. Okay, so this is why shape is very important. So if we are following a very smooth shape, something like this, for example, if this is my ducting shape, now the air will travel very smoothly. So this is the shape and the material of the duct. See, suppose for example, if you are not following the proper gauge of the material, or if the material selection is very poor, so this will also affect in the friction losses. Okay. And also the length of the duct. Suppose, for example, if you have a very lengthy duct, very lengthy duct, so what happens? If you are going for a very lengthy duct, so there may be chances that there may be friction losses. So this is the reason why you have to follow all these 4 points. Okay. So this is very important point. So friction losses can be reduced. Now, what is the meaning of size? See, size means you have to follow the aspect ratio. Aspect ratio says that we have to design our ducting in such a way that the ratio of the width by height should be 1:4. So this is the size. So our size should not go beyond 4 and it should not go below 1. So this is the meaning of size here. So let us see all these points, and obviously the noise level. So whenever you design any undersized ducting, if the height of the duct is less, so obviously the velocity will be more. So that will create a nuisance to the people. Okay. So anyhow, all these points I have written here in detail. So as I told you that space availability, like we have to provide the coordination with other MEP services. So we should always follow. Okay, we should always know what is the height of the false ceiling available with us and how much area is required for the ducting we have to decide. Okay, so this is the very important point here. Similarly, air friction losses, as I told you, it is affected by the duct size, shape, and the material and the fittings used. See, fittings also play a very important role. Okay, sometimes what happens, you are using some improper fittings. So because of the improper fitting, you have not jointed the fitting properly. Some air will be leak out from that particular ducting. If you remember in our HAP calculation, we have considered 5% duct leakages. It means that we can accept 5% leakages. Suppose if you are transferring 1000 CFM, so 5% of 1000 CFM will become 50 CFM. So if 50 CFM is leaking out, it's not an issue. Okay, so that is why you should use a very proper material, duct size, shape, fitting, everything we have to use very properly. And the most important thing is we have to follow the gauge here. Like ducting will be given in the gauges, like 22 gauge, 24 gauge, 20 gauge. Okay, so this is the reason why it's very important. Okay. Okay, and similarly, as I told you, noise level, an undersized duct system means the one which is having the lesser height. The height of the duct is less means it will become the undersized ducting. So it will always create the objectionable to the people. So that is why what you have to do means you have to follow the aspect ratio. You will come to the aspect ratio. And sometime what happen, you get the duct heat transfers. Okay, sometime what happens, the ducting is going through the hot area. So when the ducting is going through the hot area, so what happens, there is some heat transfer, or the air which is inside the ducting, it will get little bit heated. So that things also will affect in the friction losses. Okay. So here again, you can see friction losses in the ducting. These are the four major parameters: the velocity, duct size and shape, duct material, duct length. Even the velocity also causes the friction losses. Okay, another point I can write here, the velocity. Why velocity means if the velocity is high, if the velocity is very, very high, so what happens? The air will travel with a very higher speed. So it may cause some damage. Okay, so this is the reason. This is the reason why you have to maintain the velocity also. Okay. Now, to maintain this velocity, we have to follow the codes and standard. Like ISHRAE also has given and the ASHRAE also has given the velocity which we have to maintain for our, what you can say, for our design. So let us see that. We have the three types of classification: low pressure or low velocity, medium pressure or medium velocity, high pressure or high velocity duct system. So it's simple. You can see that low velocity system is the one whose velocity is less than 1968 FPM. See, and whose static pressure is less than 2 inches. So this is very important point, low pressure or low velocity duct system. So here the velocities are already defined. Okay, velocities are already defined. The velocity should be less than 2000 FPM. Okay, and the static pressure, the pressure calculation, ESP calculation should be 2 inches, less than 2 inches or 2 inches. This is called as low pressure ductwork. And where you are using this low pressure ductwork system, see, everywhere we can use this low pressure. Like for example, hotels, office building, commercial buildings, malls. Okay, wherever you are seeing the ducting, everywhere we are using the low pressure ductwork. Okay, in banks, or you can say in offices or post office, wherever it is, in hospital, general areas. Okay, everywhere the duct system, what we are seeing, that is considered as the low pressure ductwork. Similarly, another type of system comes medium pressure or medium velocity ductwork. So here what happens, your velocity will remain 2000 FPM, but your static pressure will increase from 2 inches to 6 inches. Where we are using this medium pressure ductwork? In the operation theaters, in the pharmaceutical laboratories. Okay, these are the areas where we are using this type of system. Okay, so this is very important point here. Okay, and where we are using now, in the medium pressure ductwork, we have to maintain the positive pressure also. So basically what happens, 1 minute. See, basically what happens when you see the operation theaters. So usually in the operation theaters, what happens? We provide the positive pressure. Means, what is the meaning of positive pressure? See, if you are providing the positive pressure means the inside air. Okay, this is the positive pressure and the outside is the negative pressure. So the inside air should not escape into the, the outside air should not come into the inside air. Okay. So that is why in the operation theater, we are providing the positive pressure, because the air should be continuously provided to the patient who is in the ICU or in the operation theater, because that air is very important. Because whenever the person is going inside the operation theater, basically he require the oxygen or the air. So that is why our HVAC plays a very important role here. We have to provide the continuous positive pressure here, and the cleanest form of air we have to provide. So what we do means, usually in this case, the velocity should be given in 2000 FPM, but static pressure will be increased here. Okay, only this is the thing what we are doing here. Okay, so this is a very entirely different topic actually. Clean room is a very different topic. Okay. Just a minute. Okay. So this is the medium pressure. Next comes the high pressure. See, basically where we are providing the high pressure means it's very simple. Suppose, for example, if you are doing designing for the ships or the aeroplanes, so what happened? The aeroplanes are traveling in the with a very what you can say, in the atmosphere. So the atmospheric pressure is very high. So obviously we have to provide the high pressure, means the velocity should be greater than 2000 FPM. Okay. So this is the reason what we have to provide here. Okay. 1 minute. Okay. So these are the three classifications. Now, normally what happens, see, high velocities are good in aeroplanes or ship, but high velocities you cannot provide in the office areas. Okay, high velocities you cannot provide in the normal, any normal commercial building or for general people, because what happens, that high velocity can damage the ducting also. Okay, so here some points are written. High velocities in the duct results in smaller duct and hence lower initial cost, lower space requirement, but higher pressure dropped, hence larger fan power consumption, increased noise. So that is why recommended air velocities are given. So this is the recommended recommended air, duct velocity as per ISHRAE is given here. So this is for the main duct, this is for the branch duct, this is the application. And these values are given in FPM here. So whenever we are designing the duct system, we are going to follow this velocity here. The same thing is given in CIBSE guide also. See, this is the international code, this is the Indian code. Okay, so you can see that they have given here. And here I have written one point. If nothing is specified, then a velocity of 5 to 8 meter per second is used for main duct, and a velocity of 4 to 6 meter is used for branch duct. Okay, so these values you can follow here. So velocity is already given as per ISHRAE or CIBSE guide. Only thing is what you need to do means you need to calculate the duct sizing. Okay. Next point, some points are given about the round ducting also. See, basically where we are using this round ducting means, see, round ductings you have seen in some of the supermarkets. Okay, in some of the supermarket nowadays what they are doing means they are going with the round ducting. So there are a lot of advantages of round ducting over the rectangular ducting. For example, round ducting doesn't require the much fittings. Okay, the round ducts are very easy to join also. It doesn't require the much fitting. Okay, this is one of the what you can say main advantage. But the disadvantage of round ducting is that, see, you cannot depend upon the round ducting. Okay, because normally what happens, this round ductings are, the material of the round ducting is not much compatible as compared to your what you can say rectangular ducting, but still you can go with the round ducting also. Suppose if you are going with a GI material of round ducting, you can go. So normally you will see that these round ductings you will find in small cafe areas, suppose small restaurants, in small commercial what you can say shops, in small supermarket you will find the round ducting, or you will find the oval ducts, either round duct or you will find the oval duct. So these are the two ducts which also looks aesthetically, this also looks very good. Another disadvantage of this round ducting is that, see, this round ducting will take up much space. Okay, it will take much space as compared to the rectangular ducting. So this is one of the major disadvantage of the round ducting. So that is why you will see that in most of the commercial building, we go with the rectangular ducting because of this space. Okay. Otherwise, it is very simple, and what you can say, it is a cost-effective, very cost-effective option. And there is a circular equivalent of rectangular ducting. Now the question is how to select the round ducting means. See, you have to first calculate the rectangular duct sizing, and by using this table, you have to select the what you can say circular ducting, or it is called as circular ducting or round ducting. So anyhow, these things, everything we will see in our next sessions, how to follow this table, how to use this table. Okay, so this is a table given in the SMACNA code, and I think this is given in 𝐒𝐻RE also. Every codes and standard will give you this type of tables actually. Okay, now this is one complete component of the ducting. This is the AHU. Now suppose this is the main duct, this is the round ducting, this is the transition piece, rectangular to round, and this is the grill, and here we have the VCD. So many things are given here. Anyhow, we will understand this step by step in our next upcoming sessions. Okay, so we will understand this. Okay, next. Now, as I was telling you that the gauge of the material is very important here. See, now what is the meaning of gauge here? So you have to understand one thing here. See, the gauge, the difference between the gauge and the thickness is that, see, thickness will talk about the thin and the thick of the material, but gauge will talk about the quality of the material. See, quality of material is a different thing. Suppose, for example, if you remember, like if you go to any furniture shop, so the furniture guy will tell you that this furniture is matte finish. Okay, this furniture is so and so finish. So the meaning of finish is the quality, and quality is nothing but the gauge. Okay, lesser the gauge, better the quality. Okay, so just I will tell that 18 gauge is more better than 20 gauge. 20 gauge is better than 22, 22 gauge is better than 24, 24 is better than 26. Okay, and here the SMACNA has given the standard dimension of the duct here. We have to follow this ducting. Suppose if my size of the duct is 500 by 300. So simply which gauge I am going to select. So that is already given here. Suppose if my size is 500 by 300. So my longest side is 500. So I will come and I will select 24 gauge. So this is the simple form which I am going to select, 24 gauge. Okay. So anyhow, we will come to this topic when we do the duct designing. Okay, everything is covered here. Similarly, they have given for the circular duct for the ventilation work. Suppose if you are doing any ventilation or heating system, okay, and you are using the circular duct, you have to follow this table. And similarly, this is the sheet metal gauge and this is the thickness in inches. Okay, so depending upon the thickness, gauges, we have to follow the thickness. This is what is given here. Okay, now there is a formula to calculate the duct leakages also. If you remember, I told you 5% leakages are acceptable, but there is a formula given here. So this formula is depending upon the static pressure. So depending upon the static pressure, the SMACNA duct leakages can be calculated. So here you can see that we have CL P to the power 0.65, where CL is constant. So CL can be calculated from here. You can take this value. Then P, what is the meaning of P? P is the static pressure. Okay. static pressure, like for example 2 inches, 3 inches, whatever it is. So if you input the value, you will get the answer in CFM per 100 feet. So whatever the value you are getting here, this value will become CFM per 100 feet. So this is the SMACNA has given the calculation for duct leakages also. Suppose in interview, if anyone is asking you how to calculate the duct leakages, so you can quote this formula also. Okay. This is given from the SMACNA here. Similarly, duct designing method, we have the 3 methods. So anyhow, these methods we will discuss when we do the designing, but I will give you one rough estimate, definition here. See, equal friction means, the meaning of equal friction is that you are maintaining the constant friction losses. Okay. Or we can say we are maintaining the constant head loss. Velocity reduction method means initial velocity is more and final velocity is less. Here what you are doing means you are reducing the velocity here. So you are maintaining the initial velocity and the velocity you are reducing. Okay. And modified equal friction method means, see, usually it is also nothing but it is the equal friction, but it is modified. So what is modified means, suppose for example, your size of the duct is 500 by 400, but you want to modify the duct size. So what you are doing, 500 by 350. So that is the modified equal friction method. These are the 3 methods, the designing method. So more popularly is the equal friction method. Okay. So we are going to follow both the methods here. We are going to follow all the 3 methods. Okay. In our example, what we are seeing the example, we will follow all the 3 methods and we will do the duct designing. And after that, we come to the aspect ratio. So as I told you that aspect ratio is defined as width by height. Simple definition, width divided by height is called as aspect ratio. Maximum permissible aspect ratio is 4:1. See, means your value should come between 1:4. That the ratio of width to height should be in between 1:4. See, in this example, I got 2.2. So it is in between 1:4. Okay, so this is the aspect ratio. So, okay, after that, some procedure is given here about the duct sizing. So anyhow, I will not discuss this now because obviously in the next session, we are going to follow this duct sizer calculation only. We are going to understand this duct sizer software and we are going to do the calculations. Okay. So here you can see that I have written the 3 aspect ratios. 3 sizes are written. So always remember that the best aspect ratio is the lesser aspect ratio, as I told you. And lesser the aspect ratio, the cost of the ducting is also lesser. So this is what we have to do. Now in our next session, we are going to design the duct system. What is the principle of the ducting? How to design the ducting? Okay, what tables we have to follow, and the duct McQuay duct sizer, how to use the McQuay duct sizer. Everything we will see in our next session. Okay, so this is how we are going to proceed further. Okay, so already we have the example. So what I am going to do means we are going to design the ducting double line, and we will place all the ducting, everything we will do in our next session. And then you will understand. See, you will also understand after doing the calculation which method is more suitable. Okay, and which method will give you the more costing, or which method will give you the lesser costing, which method should we follow. Everything we will understand. Okay, so in our next session we will be focusing on the duct design. This is the very important calculation, because most of the time you will see that in the building you will always find the ducts. Okay, ducts are always running from everywhere. So that is why it is very important that you should run the duct you should learn the duct design very properly. So that is why we will discuss all these 3 methods in the duct design, and then we will proceed according to that. Okay, so I hope you understood this. Any questions you want to ask? If you have any questions.
One doubt, sir. Velocity pressure is there, no, sir? What is the difference in little bit explanation? Please give
Velocity
me.
pressure?
Yes, sir. If
See,
you
velocity pressure is nothing. See, when you switch on the fan, So what happened when you switch on the fan? What happened? The air is traveling. So the air
Okay,
is
sir.
traveling with how much velocity? That is called
Okay.
as velocity pressure. 1900 FPM, 1500 FPM, 2000 FPM. Okay, so this is called as velocity pressure.
If I increasing the pressure means what happen velocity?
See, that is what you have to understand. Velocity and pressure are inversely proportional to each other as per Bernoulli's equation.
Okay.
If the velocity increases, static pressure decreases. If the static pressure increases, velocity decreases. So this is the Bernoulli's theorem. So our ducting system also works on the same principle. Okay.
Okay, sir.
Yeah. Okay then.
Another thing, sir, in our project, they are using three things. One rectangular duct, circular
Round
and
and
round
yes,
and elliptical.
yes.
So if in ceiling area, they are using the rectangular and they are using insulation also.
Yeah,
In, op
insulation you have to provide. Insulation has to be
in
provided.
open area, without ceiling area, they are mostly preferred rectangular and circular.
Yes.
So what is the difference if you are another thing is rectangular they are using insulation, but circular and elliptical they are not using the insulation.
Yeah. That is the cost-effective solutions actually. See,
Okay.
your circular or elliptical ducts are not designed for the uh, bigger area. Suppose, say, rectangular duct you have to provide. It is for the long term. Okay.
Okay.
And
Okay.
insulation is always best because you are supplying the cool air. See, what is the temperature of air inside the duct, you know? The temperature is somewhere around 10 degree to 12 degree. Okay,
Yes, sir.
just imagine if my temperature of air is reduced. So what happens if the temperature of air is reduced inside the ducting? It will form water droplet.
Yes.
And in that much of confined area, snow formation will quickly become. The air will quickly, the temperature of air will drop and it will make lot of water moisture droplets, and those water droplets will become what you can say snow. So if you provide insulation, so at least you are giving some heat to the duct also, and you are also avoiding the snow formation
Oh,
because insulation is very important. Otherwise, what you have to do means you have to follow the design in such a way that your ducting should not, sorry, your ducting should not, what we can say, that the air temperature should not drop inside the ducting. Okay. So that is why insulation is very important. So insulation is a different concept here. Okay. So
in, fu-
anyhow,
in future that will be discussion is happens regarding insulation and with how much thickness is required regarding that
that is
also.
already given in, you have to just consult with the manufacturer.
Okay.
Manufacturer will explain you. Like they
Okay.
have 19 mm, 25 mm, 50 mm. Various
Mm.
different types of insulations are given. For duct is different, pipe is different. You have to discuss with the manufacturer.
Okay.
Okay. So, okay, let's stop here for today. We'll continue in the next session. Thank you. I will end.